question 4, we're being asked to identify the parent function out of g of x. So here's our function g of x that we're going to graph. Well, I first want you to identify what is the parent function that really makes up the basic shape of this graph. So the parent function that is in here that is really creating the features that are going to take the shape of this graph is the absolute value function. So the first response I was looking for was making sure that you could identify that our basic parent function is nothing more than the absolute value of x. This is the graph that it's going to look like, or at least most resemble, but g of x has some transformations, and we're going to describe those transformations in a bit. But I asked you to graph f at x, so the absolute value of 0 is 0, the absolute value of 1 is 1, the absolute value of 2 is 2, and so on. And we can do the absolute value of negative 1, which is 1, the absolute value of negative 2, which is 2, and so on. So this is the graph of our parent function, absolute value of x. Now we're going to make some adjustments to it. We're going to change it. You can either think that there are 3, or you may think there's just 2 transformations. I tend to think of them as 3. Using your order of operations, the first thing we're going to do is we're going to have a horizontal translation, and it's going to go 3 units to the left. When it says plus 3, you go 3 left. Then I also have a reflection and a vertical stretch. Now you can do them both at the same time or separately. I'm going to do the vertical stretch first, and that's by a factor of 2. And then I'm going to have a reflection across the x-axis, once again, because of the negative. So those are our transformations. Now you can use your defining points as we did with the other ones. This is the order pair 0, 0. This is the order pair 1, 1. This is the order pair 2, 2. And graph some over here. This is a negative 1, 1. This is a negative 2, 2. And go through our transformations we did before. So I wrote down the order pairs. I'm just going to do 3 of them. Negative 1, 1. The order pair 0, 0. And the order pair 1, 1. Our horizontal transformation has to happen first. That means our x values are going to get transformed. We're going to go 3 units to the left, which means we're going to subtract 3. So it's going to be, it's a horizontal translation. Left 3 is going to be negative 4, 1. Left 3 is going to be 3, 0. Left 3 is going to be a negative 2, 1. Next thing I'm going to do is I'm going to do our vertical stretch. Just go vertical stretch. Now since it's vertical, it'll only have an impact on the y values. So I'm going to stretch them by a factor of 2. So negative 4 times 2, 3 and 0 times 2, and negative 2, 1 times 2 is 2. And then I'm going to use the reflection part. Now the reflection across the y-axis, so we're going to reflect across the x-axis. This is only going to have an impact on the y values, and we're going to negate them. So it's a negative 4, negative 2. It's 3, you negate 0, it's still 0, negative 2, negative 2. So these are the order pairs that we're going to graph. I could interchange these two and make no difference. I could reflect first and then double, or I could combine the two, and in this I could do the vertical stretch along with the reflection, and just multiply by negative 2. All the y values times negative 2 and go directly here. Take this times a negative 2, go right here. Take this times negative 2, go directly there. So there's different approaches, but in the end, I want to make sure that I can graph these ordered pairs, which are negative 4, negative 2, 3, 0, negative 2, negative 2. And then since they're straight lines, all I need are 2 points to create the graph. And now I have my new transformed absolute value graph.